So if I'm on the y-axis, any point on the y-axis has to look like this, 0 something. True? And of course, any point on the x-axis has to look like what? Number 0. I love it. I like it. I like it. And that's going to have a big deal today with when we talk about x-intercepts and y-intercepts. We sort of talked about them a little bit before. But the more you understand this, the more sense it makes what we do. So let's talk about it right now. If I have an equation, let's not put there. Y equals 2x minus 5. And I just want to find the y-intercept. That's all I want to find. And we know that any y-intercept has to look like this. Any y-intercept has to have x equal to 0. I like it. So how do I force that equation to tell me where it hits the y-axis? I make x 0. I know that's true. I love looking at it like that. I'm going to force the equation to tell me. Just sit the equation down, turn the bright light on, right? And so if I let x equals 0, I'm going to find what the y-intercept is, because I'll end up at the point 0 comma something. And that is the y-intercept. That's where it will be on the y-axis. Are you guys with me? So if I let x equals 0, what do I get? I love that people get negative 3. It's not negative 3. 2 times 0 is 0. I like that. I like negative 5. That's awesome. So what point do I know this goes through? The only point I know what? 0? When x is 0, y is negative 5. What if I wanted to find the x-intercept? It's amazing. What do I do? Yeah, makes y 0. This is true forever. So in my last math class, I had equations that had 11 variables in them. Oh yes. Right? We're not going to do that. But if I wanted to find the w-intercept, what did I do? I made all the other letters 0. That holds forever throughout all of mathematics. It's insane. You're learning something right now that works in Math 896. I think that was the last math question. Yeah, buddy. Sorry. Oh, Jeff is impressive. So it's always true. Always true. People forget this but if I want you to find an intercept, a blank intercept, you make the other variable 0. Bam, done. All right, maybe. Some of you guys look, like I'm not sure how to feel about that. All right. So that's one thing. So if I wanted to graph this now, so how do I get, so this is the y-intercept. And what did we just say? How do I get the x-intercept? Set 0 in for y. I like it. So I get 0 equals 2x minus 5. How do I solve that?
Add 5.
Add 5? That's great. It's 5 by 2. So get x is 5 halves. What point then is that? No slope yet. I haven't done any slope.
0.5.
Can you please sound a little less?
A little
less enthusiastic. Calm down. 2.5. Alright, so I know some of you guys, this is really old news. That's awesome. Just sit there and be bored for a minute. I want everybody up to speed on what the hell's going on. And all I really, really need to graph a line is how many points?
2.
I just need 2 points, really. Normally you do a third point just to make sure that the first 2 are good. I feel pretty damn good about what we did. That was pretty easy. So I'm just going to graph the 2 damn points. So how do I graph this line? You guys are, you're doing good so far, man. Keep going. So yeah, so what's the y-intercept?
0 minus negative.
And how do I get there?
0.
Be more specific.
On the left.
Down. 5.
Just 0.
I like it. Don't go anywhere, left or right. That's a quick way. Just go down 5. That's a quick way. Yeah. I like it. You guys are like, what do you want from me? And then I know this one. Where's that? I like the way you said it, Keanu, even though I like what you said, not the way you said it. 2.5 is easier for me to think about when I want to go graph. Where's 2.5? 0?
Right.
Right?
Yeah.
2.5.
Here, between.
Up and down, none. And then there's my line. Woohoo! That's pretty good for me, yeah. Jeez. Normally I have to make the points really big. If you are anywhere near as messy as I normally am, you desperately want to get like graph paper maybe, or at least a ruler or something. Your graphs have got to be, if you turn in homework where all the graphs are this, no, that's bullshit. Give me some scale, give me some work. Don't just give me that. That's crap. Right? Sorry. I mean, if any of you guys are headed into 110, anybody got to take 110 that you know of? And then anybody have to go to 176? Yeah. Oh yeah. 176, you're going to be graphing every damn thing in the universe. Holy shit. So you got to really get it down now, the basics, so you can build on it. All right. So I'm sorry. I don't know if a question got me going off on that. Any questions from homework? Any? Yeah.
Number 36 in section 2 or 3.2.
3.2?
Yeah.
Yeah, we did. I love you guys. Let's see. $36. Oh yeah. I think that one just comes out gross. Yeah, let me remind you guys, last time, didn't we make a table of values? If I remember correctly? Didn't I give you an equation? We made a table of values, and then we graphed it, and then I did my whole spiel about the quickest way to answer the question, what's all the answers to this equation, is to graph the damn thing, right? You can't list them all. Good God. There's an infinite number of them. It'll take a while. So this one says, given this equation, use these values to make a table, an XY table. So I go ahead and start my XY table, and what do I know? I know like Y is negative 1, 0, 1, 2, and what do I have to figure out? What X is. This one is going to be the what?
0.
What's the name of this one going to be? I make Y 0 when I want to find the X-intercept, you guess. Do you have to know that for this problem? No, but I don't care. I'll still teach you. So what do you do, for example, how do you figure out this number? I got to figure out these 4 numbers here, right? The pairs that go together. Sorry. Yeah. When Y is negative 1. So this is, the question this is asking is, when Y is negative 1, what is X? When Y is 0, what is X? That's why they're pairs that go together. So when you plug a negative 1 in, how do you solve that? Negative 6 minus 4. Negative 10. So you get X equals 10 over 4, which is 5 over 2. So there's 1 point done. Is that cool?
Yeah, that's where I didn't know if that was okay to leave it like a fraction.
Oh yeah, it's fine.
Okay.
I can't remember. All I want you to do here is make a table.
Yeah.
If I was going to graph it, I would change them into decimals.
Right.
If I'm going to do it by hand, I'm going to, yeah. Cool. But you can leave it like that's fine. Is that cool?
Yeah.
Let that part be nice. I mean, you should be able to plug stuff in and get stuff out. That's old news, right? It's just couched in this new stuff. Anything else from homework? Okay. All right. Did you guys hear about the... Did I tell you about the asteroid that's going to be
What?
coming really close to the Earth?
Again?
Did I tell you about it? Again, no. It's going to come within 11,000 miles of us possibly, and that sounds really far away, but it's closer to us than the moon. So scientists are freaking out.
What happens if like something like that hits it?
Well, what do you think? You've seen the movies. Either you've seen the Bruce Willis movie or the other one. I don't know the other one, right? It was a Deep Impact and Armageddon.
Yeah.
And poor Deep Impact is like, where's some standard? No, I want to see Armageddon.
I don't know, but if it hits like China, we'll still be alive here, right? Yeah.
For a while. I think it depends on how big it is, right? Depends on how big the thing is, and it could kick up a lot of dust that would cover, and then we'd have the equivalent of nuclear winter, right? We'd have too much stuff in the atmosphere, we can get sunlight, all the plants would die, and we'd have a rough time. Right? So stay awake at night. Yes?
It's about the homework now.
Sure, I'm sorry.
Okay.
I
For the same section on 39, we can pick any values, right?
Yes, cool. So this, they gave you these values in number 36, but then starting at number 39, you make your own table values.
Okay.
I normally pick -2, -1, 0, 1, 2, stuff around 0, some negatives, some positives. Cool. Let's do one of those real quick here. Make sure I'm on the same page here. So if I had to graph this, using a table of values. So if some of you guys remember how to do this using the slope and the y-intercept, you can't do it if I say this. You have to use the table of values. We will learn the slope and stuff here pretty soon. So I make my XY table. What kind of stuff do I want to throw in? 0 is always a good point, right? Let's use -1, 0, 1. I like it. Some negatives, some zeros got to be thrown in there, and 1 is good. I like it. So when you plug a -1 in, what do you get?
-3 minus 4. 7.
7. There it is. I really want to make sure everybody's with me here.
Yeah.
You guys all with me? The -1, I plug it in. And where did the -1 come from? From me, from you. Right? You just make whatever you want to. I'm not going to plug 80 in there. I'm not saying. I'm going to plug some nice small numbers in. If these numbers, if you pick numbers that, and this is coming out to be 27, and you don't want to graph 27, I don't want to make a graph go that far, then don't use that point. Right? Keep going until you get some nice numbers. It doesn't matter which point. How many points are there on this line? How many points are on this line? How many points are on that line? No. An infinite number of points. When I want to graph it, what do? I find specific points, and then how do I find the infinite number of other points? I fill it in. When I draw that line, it's like I'm making an infinite number of little tiny points. Are you guys with me?
Yeah.
So just because I do certain points, I can't do every freaking point. That's the whole point. I just want to do certain points, fill it in, and then all the answers are visual now. Because there's no way I'm going to list them all. Shit. There's an answer for -1.072224. There's an answer for pi. There's an answer for square root of 11. I'm not going to do all that shit. I'm going to use some nice ones and then fill them in. But I really want you to understand, just because you pick -1 and you get 28 here, you don't have to use it. Just get until you get some nice numbers, and because you're going to go through -1, -28. If that's the right answer. You just make the line. It's going to get there. Do you guys understand?
Yes.
Because I hate when people do that. They think they have to use all the points they got. No, that's the point. Get some nice points.
Do you just choose any random number? I assume you pick
I definitely do at least these 3. And when we get to freakier functions, I think we did it squared last time, if I remember right. Didn't we? It was squared. Yeah, we did. Parabola? Sure we did. You guys like, no, Jeff, no. We're not officially going to do it. I just did it just to show you the process still works. But when I get freakier functions, I use at least 5 points. And I normally use -2, -1, 0, 1, 2. Some negatives, 0, some positives. I like it. We're investigating the line or whatever it is. So to keep going, when you plug a 0 in,
-4.
yeah, you do this real quick. When I plug a 0 in, that goes away.
0.
Y is -4. Kick ass. Are you guys with me?
Yes.
All right. And then number 3, when you plug a 1 in,
-1.
yeah. 3 times 1 is 3, minus 4 is -1. Kick ass. And then how do you graph this?
Easy.
Easy?
So when you're asking us to make the tables or on the homework, how many do you want? How many points do you want?
I'd say 3.
3.
Yeah. And the reason you do 3 is if you go to graph it and you get this and this and that, you're like, oh, shit. You don't connect those. That's telling you one of these is wrong, right? Okay. So let's see. How do I graph this? I just plot the points. I got to get down to -7 if I want to use that one, right? That's not too unusable. 1, 2, 3, 4, 5, 6, 7. There you go. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. Okay. So -1, -7?
Down.
Down 7? Kick ass. 0, -4.
No.
Just down 4. I like it. Now you guys know how to say it.
Right one.
Right 1.
Downward.
Down 1. Kick ass, and then connect them. Sure. So that, whatever that point is, and of course it's not perfect because I did it by hand, and I suck at drawing, it's obvious, but that's pretty good for me. If I did this perfectly, that point, whatever the hell it is, I didn't calculate it, but it would work in that equation. All right, so what about pi? Pi is about right there. Well, there. Go get your own answer. Leave me alone. That's what you're saying to people. What are all the answers? There they are. What about for this one? Oh, just keep going. That's what the arrow means, right? I like it. I like it. Yes, ma'am.
Just out of curiosity, I'd never want to do it, but
I like it so far.
could you do like -1, 0, and then 2? Instead
Yeah,
of
sure.
doing,
Of course.
like, or do they have to be in
Yeah,
order?
let's do one real quick. I want to show you what to do if there's a fraction in there. I mean, that's nice. 3's a whole number. It doesn't matter. But you could be smart about the numbers you plug in. So, for example, bless you. What if I had this? You see, -1/2 x plus 3. I like it. I can make it worse. Let's make it worse. -1/4 x plus 3. So if you want to play along. So I want to be smart about what I plug in. I'm not going to plug 1 in because I'm going to end up with some ugly fraction, right? So I want, what kind of numbers do I want to plug in for x?
4.
Why 4?
2.
Because it would kill the fraction. So very good point you have. You don't have to go perfectly in order. I'm going to plug in 0, and then around it I'm going to plug in the 4s. Which makes sense. And why am I allowed to do this? Because I can get any freaking points I want to and then just connect it. I could plug in 80 billion and make my scale big. You know, and still, when I make the line, it's still going to catch all the answers. It's going to catch all the answers. So it doesn't matter which answers you put here. When you graph it, you're giving all the answers. I think there's a fundamental misunderstanding. That's why I'm spending a lot of time with the basics here, right? Even if you know how to graph, I don't think you heard ever some of the stuff I just said. I mean, this is really the story behind graphs. So what do I get when I plug a -4 in? It's -1/4 times -4. What happens? The negatives cancel and the
4.
4's cancel. So I get 1 plus 3.
4.
Great. When I plug a 0 in,
3.
3. You guys, is that cool?
Yeah.
Yeah. And when I plug a 4 in,
-4.
careful.
Oh, no.
So these go away. -1 plus 3. 2. And that's why you do 3 points, because it would very quickly be obvious that something went wrong. Right? Ding, ding. Oh. Now watch this. How much did x increase by from here to here?
4.
Yeah.
It went up by 4. So it went up by 4. How much did y change from here to here?
1.
It went down by 1, right?
Oh, yeah.
And what's the slope? Slope? What's this number? -1/4.
Oh.
So a lot of you guys already know that whatever's in front of the x is the m. And I think most of you guys should know mx plus b coming in here, but that's really why. I call that the amplifier. In this case, it's a dampener. Any musicians in here? Amplifiers, dampeners? No? Yes? So whatever x is, this is going to do -1/4 of it. So if x changes by 4, y is going to change by -1. That's why the slope does what it does. So when I put a 3 there, how much did x change from here to here? It went up by 1. How much did y change?
Up by 3.
Up by 3. 3/1 is 3. So that number in front of the x is how much y changes as x changes. If x changes by 1, y is going to change by -1/4. But I didn't want to do 1. So if x, every 1, this goes down by 1/4. So if it goes 4, it's going to go down by 1. 8, it's going to go down by 2. Shit. I mean, that's the only reason. That's why it's the slope. It's not the slope because we went, let's make that the slope. It's the slope because that's how it freaking works. It just is how it works. Okay, sorry. So if you have a fraction there, you can be smart about the inputs you use. I'm not going to use 7. Good Lord. I'm going to use multiples of 4. So if there was a 3 down there, I might use 6, 3, -3. I like it. Kick ass, kick ass. I know, man. Okay. Anything else from homework?
What if I do?
3-2?
Yes. Y equals X.
Oh, all right. Yeah,
Just
that.
put one up here.
The really easy ones sometimes are the hardest ones. Figure that out. Y equals X. What is this XY table going to look like? So when X is -1, Y is -1. When X is 0, Y is 0. That's the best equation in the universe. Right? If I make X 1, then Y is 1. So then graph it, it's easy, right? Is that cool?
Yeah.
I like it. And what's the number in front of X?
1.
1. So when X goes up by 1, Y goes up by 1. Cool. I like it. Cool. Anything else? All right. Let's get into 3.3. We sort of talked about... So 3.2 is just that. It's making your own tables, graphing, using tables, stuff like that. I don't want to see anybody using slopes and intercepts. Even if you know all about it, you got to do what's in the section you're in. 3.3, we talk about... The only thing I got to talk about in 3.3... Where'd you go? We already talked about X and Y intercepts. So that's in 3.3. But there's also special cases of lines. And what do I mean by that? I don't know. I mean like this. What about this line? Y equals -3. Immediately you realize, is there an X in there? No. So the right way to look at this is, since there's no X in there, X can be whatever the hell it wants to be. There's no restrictions. If I have an equation where Y equals X, X can't be anything it wants to be. It has to be whatever Y is. So there's a constraint, right? This guy says Y has to be -3, and X can be whatever the hell. So if I make X 0, there's no X in there, right? But what's this say? What's the equation say? Y must be -3. So what's the output? -3. What if I make X pi?
-3.
So what if I make X squared root of 11?
Negative.
What if I make X 1?
Negative.
Because what's the equation say must be true? Y must be -3. It's got no control over X. X can do whatever the hell it wants to. So, to make sense of this, now you can just plot these points, but I want you to realize this a different way. If I say Y must be a certain number, what happens if I change Y? What happens if I change Y? Which direction do I go? If I go from Y equals 1 to Y equals 2, which direction do I go? That sounds weird, I know. But if I'm at Y equals 1, and then I go to Y equals 2, which direction did I just go? Left, right, up, down? Up. If I'm at Y equals 1, and I go to Y equals 2, don't I go up? Alright, so what I'm trying to say is, if Y is not allowed to change, I can't go up or down. I can only go left and right.
Direction, yeah.
So Y, so when I go to graph this, if I can use the table of values, sure, but I'd like you to realize what's going on. Y has to be -3. So at 1 it's -3, at -1 it's -3. So I'm constrained, I can only move left and right. X can be anything it wants to be. So I get all the X values, but I only get one Y value. I don't get this Y value. It can't go up that way because it's not allowed to. So what kind of line is that? I love it. Horizontal. I like it. So what do you think is going to be true about this? That's insane. X must be 2. There. Bam. I don't have to do any work. X must be 2. So what screws people up is when they try to force it to act like the other ones. That's a special case. It's easier if you realize it. X just must be 2. That's all I care about. Y can do whatever the hell it wants to because it ain't in there. How we doing? All right.
Good.
Good. So let that be easy. If you try to force it to work like the other ones, it becomes really hard. Wow, that's really all there is in 3.3. Let me make sure I didn't miss. No, okay, good. Yeah, there's X and Y intercepts, and then there's horizontal and vertical lines. That's all there is in section 3.3. So what I really, really want to spend time on today is 3/4. The slope. Like some students call it slop. I love that. We're trying to stick with my math. So let's talk about this from a purely physical standpoint. Unless you really love mountain climbing, would you rather climb this mountain or that mountain? Yeah, some of you guys, if you really love it, you want a challenge. In fact, you might do this one and then that one, where you're like, oh, I don't know. But this one would be easier, right? Which one's got a gentler slope?
This one.
Yeah, this one's got a gentler slope. So slope in math is the same as slope in the real world. Thank God. It doesn't feel like it happens all the time. So what's going on? Why is this slope better than this one? So, just think about this. Let me draw this picture. So if this was a handicap ramp, and there's a door here, and on the other side there's stairs. You guys with me?
Yes.
Leave me alone. And there's my man. He's got a cowlick. He's got a major, different hairdo. I don't know. It looks like a hoot from Hugo. Which one should have a gentler slope? And actually, which one obviously does? This one does, right? It's got to have a gentler slope. That's the whole point of a handicap ramp, is to make it, or switchbacks. When you're going up, instead of going straight up the mountain, you switch back and switch back, so your slope, your change in elevation is spread out. If you change elevation very quickly, holy shit, you're going to be, if you change your elevation very slowly, so here's the whole idea of slope. Here's my change in elevation for both. This one does it in this much distance, but this one spreads it out over this much distance. So slope is it makes sense. So let's say this is I don't know, 6 feet up, and this is 2 feet over, but this is 8 feet over. So the slope here, how much did it slope is rise? I know you guys all know this. So how much for the ramp? How much did I rise? 6. And how much did I run? 8. So it's got a slope of 3/4. Less than 1. It's got a nice gentle slope, right? What's the slope of this one? 6 over 2, which is 3. 4 times as big as that. 4 times the slope. And that's the whole point of a handicap ramp, of course, is to make it gentler so that pushing yourself up there, it's a little easier on you. I like it. Anybody ever driven down towards the airport and you got that one place where there's a stop sign and then you're like, you don't do that.
Under a bridge?
Huh?
Is it under a bridge?
And then you go under a bridge, I think, after that. You remember?
Yeah, I know.
You know what I'm talking about? Laurel?
Yeah.
Right? Yeah. And then even in Mission Hills, I think there's a slightly steeper one back in the neighborhood. I used to live back there, and there's this insane just drop, and people live off of that street. Like, I'm sorry. You go out the front door, and you're like, holy shit. But if you've ever driven around, you'll see something called the grade of the road, right? Steep grade, it'll say, warning, steep grade ahead. And you'll see these signs, runaway truck signs. And the first time I ever saw one of those, I'm like, oh shit. These runaway truck ramps, because the slope is so big. So you'll see like I don't know, what do you want, Jeff? A 7% grade on a road. Somebody help me out. Let's figure out what this means. Grade is just another way of describing slope. A 0% grade would mean the street is flat, right? Slope of 0 means flat street. It doesn't mean no slope. It means 0 slope. And I love it, you guys. You just said the same thing twice. No, the slope is 0, not there's no slope. There's a different. What is this as a fraction?
7 over 100.
Like somebody was ready with an answer and then answered the wrong question. Like, so as a fraction, that's 7 over 100. So that is the slope. So what does that mean? For every 100 feet, I go forward, how much do I go up?
7.
7. Or down if it's this, if it's negative, if it's going down the hill. So I don't know, if you ever seen those signs, then that's what it means. So I think the highest grade I've ever seen anywhere is 11% grade, and that's pretty exciting. All right, that's enough for me. All right, you guys doing all right? I don't know if you've never seen that, then get out there somewhere. Go take a road trip. Go somewhere. Okay. So let's bring this back to math. Now that we got the physical reality, let's show you how it's the same thing with math. So let's say I'm at this point here. And I want to go to this point there. What's the slope between those 2 points? I'll call this point P, and I'll call this point Q. So I'm asking what's the slope between P and Q? So from P to Q, how much do I rise? 1, 2, 3. So now I'm directly over from it, right? So I rise, so it's still exactly the same idea. I rise 3, and how much do I run? 1, 2, 3, 4, 5. Every step you got to count, right? 1, 2, 3, 4, 5. So what's the slope? 3 over 5. Kick ass. And it's positive because it's going up as I read, right? So this slope, and we use the letter